All right, so am I good to erase? Speak now for everyone's piece. All right, so if you have your Chromebook out, please close it. You do not need it right now. So today we are getting away from finding area or finding side lengths using area of a rectangle in quadratics, and we're going into a different application of quadratics. So we're still doing word problems, but different type. And this one is consecutive integers. All right. Now, we have talked about consecutive integers before in foundations, so last semester. All right. We talked about them in terms of linear equations. So sum of consecutive integers. Does anyone remember what a consecutive integer is? Give us a try. Not really, but you're in the realm of the integer part. So just to recall, an integer can be any negative or positive whole number. All right. So in other words, no fractions, but it can be negative or positive. So no fractions, no decimals. But what's the consecutive part come into play? Nope. Right. So consecutive means that they're next to each other, or they're in a row, or they're in an order. So consecutive integers are numbers that if you were looking on a number line, they'd be right next to each other. So for example, some consecutive integers would be -2, -1, 0, 1, and 2. All of these are in a row on a number line. So all of these are consecutive integers if you're just going down the line. So 1 and 2 are consecutive integers because they're right next to each other. -2, -1 are consecutive integers because they're right next to each other. All right. Now, we also deal with consecutive odd and even integers. What does it mean if it's a consecutive even integer? So it's an even number, so two even numbers, but they're where? They'll be in order or next to each other. So, in other words, -2 and 0, 0 is technically even, are consecutive even integers. 0 and 2 are consecutive even integers. What about consecutive odd? So two odd numbers that are next to each other are in order on a number line. So -1 and 1 are two consecutive odd integers. Now, what we're going to do is that last semester you learned about how to find the sum of two or more consecutive integers. That was with linear functions. So when we set the equations, that gave us a linear equation. Now we're going to talk about how to find the product of two or more consecutive integers. And that's going to, when we set up the equation, that's going to give us quadratic. So heads up, guys. All my little sleepyheads, come on. All right. So let's look at the 8.4 journal. So your I can statement for this journal is I can find specific consecutive integers given their product using quadratic equations. So we're going to take things that we learned last semester with how to set up consecutive integers, and then we're going to use that to make a quadratic equation for us to solve to find those consecutive integers? Yes. Using. So my little sleepyheads, wake up or you're going to be standing up. All right. Now, what I did so that you guys have a very quick reference is last semester we did a written journal entry on how to find the sum of consecutive integers. What I did is that if you were in my class, this should look familiar to you because I literally took a screenshot of that journal entry and put it on the front page of your notes. All right. So if you were in my class last semester, you should have that journal entry either in your journal from last semester. If you're currently using that journal, it should be in that journal somewhere. If you weren't in my class, you should have something similar in there. All right. All the Math 1 teachers did this journal. Okay. But I put it here just so you guys could have a quick recap of consecutive integers, how to set them up, and some examples with sums. All right. So quick reference, especially if, you're using a different journal than last semester. So just a quick review of the notes. We're not going to be like actually writing them again. That's why I put them there. But biggest things you need to know. All right. First off, you need to know the definition of consecutive as well as consecutive odd and consecutive even. You got to know what they're talking about. So remember, consecutive means numbers that are right next to each other. So like 1, 2, 3. Consecutive odd are odd numbers in a row. So like 1, 3, 5, 7. Consecutive even are even numbers in a row on a number line. So 2, 4, 6, 8 is an example. Now, that's just definitions. The biggest thing you need to pay attention to is this right here. So I would either highlight that, box it, whatever you need to do, because that's the biggest part of that entire part in the journal right there. Mm-hmm. It's last semester's notes, yeah. But this right here is how you define your variables for consecutive integers, and it'll be very helpful when you set up your equations. So recall, n always represents your smallest integer. So n always represents your smallest integer. And then from there, you keep adding 1 to it in order to get to your next ones. So n plus 1 represents your second integer. N plus 2 represents the third integer in the row. And n plus 3 would be your fourth integer. Why am I adding 1 to n to get my next integer? Why do you think? Right. So for example, if I said my smallest integer is 7, what would my next one be? 8. So my next integer would be 8. How do I get from 7 to 8? You add 1. What will be the next one after that? 9. How do I get from 7 to 9? Add 2. Next one after that would be what? 10. How do I get from 7 to 10? Add 3. That's why we're doing n plus 1, n plus 2, and n plus 3. All right. Now, that's with consecutive integers, so not even or odd. The other part that you need to know is with consecutive even or odd integers, you would use this configuration. It's the same for both. So n plus 2, n plus 4. So n is still your smallest, but then n plus 2 would be your second integer of an even or odd variety, and n plus 4 would be your third integer of your even or odd variety. All right. Why am I adding 2 to n to get to either an even or odd integer? So for example, let's say my smallest even integer was 8. What would be the next even integer? So after 8, what's the next even number? 10. How do I get from 8 to 10? You add 2. What's the next one after 10? 12. How do I get from 8 to 12? You add 4. So that's why you have to add 2 here. On the opposite end with odds, for example, if my odd integer was 11, so my smallest one's 11, what's my next one? So what's my next odd number after 11? 13. How do I get from 11 to 13? You add 2. Good. So that's why you're adding 2 each time for your next integers with even or odd. It's the same for both. So whether you're doing even or odd, you're going to add 2 to your next integer. So biggest things to note, n is always where you start. That's your smallest number that you're looking for. That's usually what you solve for when we do all the equations. All right. After that, you need to use n and add either 1 or 2, depending on if you're finding just the consecutive integer or the consecutive even or odd integer to get to the next one. All right. So you need to know those setups. That's, if I remember last semester correctly, that's where a lot of you guys struggled with some of integers. You struggled with the setup. So we're going to alleviate that this semester. All right. Now, I'm not going to go through the examples because that's just some of integers, but if you need a recap, it's there if you need it. All right. Now, let's look at an example here. So on the next page, like I said, finding consecutive integers with quadratics is not that different than when we were finding consecutive integers with linear equations. The only difference is their actual setup. And by setup, I mean it's literally the difference between sum versus product. Or in other words, addition versus multiplication. That's the difference. Quadratics typically multiplication, linears typically addition when you're dealing with it in terms of finding these consecutive integers. Now, before we actually get into solving for those consecutive integers, we're just going to look at how to set it up for just solving for any number. So in other words, a rational number. And by rational number, I mean it can be a fraction, a decimal, or it can be an integer. So this first example are not going to be 2 consecutive integers just yet. We're just going to play around with the setup and just get some numbers, just to kind of get your brain thinking about the setup. All right. So let's look at example 1. So 2 rational numbers have the following property, and that is the product of 7 less than 3 times the number with 1 more than the number is found it is equal to 2 less than 10 times the number. And we want to find the 2 rational numbers that fit that description. Now, that was a lot of information that they threw in there, but let's break it down one piece at a time. So first things first, we're just finding a number that fits that description. So what I'm going to do first, I'm going to say that my number that I'm trying to find, let's equal that to n. So let's represent whatever number we're trying to find as n. Now, we're not doing consecutive integers yet. So we're not doing any of the n plus 1, n plus 2, none of that yet. All right. But we do have some words that we need to turn into math. All right. So let's look at the blue statement first. All right. What's the very first word of the blue highlighted statement? Product is the very first word. This is the first thing you should key in on. What does product mean? Multiplication. So product means you're multiplying something. Now, there are two different statements within that blue highlighted section. Which word separates the two statements? Not less than. Nope. Guys, there's going to be two different expressions within that blue statement. There's one word that separates the two. Nope. Nope. Less than. There's one word that y'all didn't say. I'm just looking at the blue highlighted. 7. I said that. I already said that. With. There you go. It's with. So, with. That's the word that separates these two expressions. So this is our separation word. So that means that this first part right here, 7 less than 3 times the number, is one expression. And then 1 more than the number is a second expression. And we're multiplying those two expressions together. All right? So that's what it means. The product of the first expression with the second expression is equal to blah, 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 blah. All right? That's what that means. So with is a separation word. That means that is where this first expression stops and we start a new one. All right? So let's look at the first expression, or 7 less than 3 times the number. What's the first word I should key in to? What's the first word I should key into in that one statement? 7 less than 3 times the number. Than. You need to key into than. What does that mean we start with? So than means that instead of looking from left to right, we look from right to left. So that means we're starting over here with the 3 times the number. If n is my number, how do I represent 3 times the number? 3n. We're just multiplying 3 times a number. So that's the first part. What's the second part of that statement say? 7 less. How do I represent 7 less? Minus 7. Good. Now, since we're multiplying this expression to another, I'm just going to put parentheses around it just so I know that we're going to do some multiplication. Now I'm going to look at the second part. So the other expression on the other side of with. So on the right side of with. So 1 more than the number. What's the first word I should What's the first word I should look at? More than. So that means we start with what? What's the only thing on the right of than? The number. So we start with the number, which is represented by n. So we start with n. And then we do what? 1 more. So what does 1 more mean? Plus 1. And since we're finding the product of those two expressions, we'll put parentheses around the n plus 1. And that's the first half of our equation. Now, we know there's an equal sign here. Which part in the question tells us where the equal sign is? What word tells us where it's equal? Is. So besides equal, is gives us where the equal sign is. So that means that on the other side of is the second half of our equation, which is 2 less than 10 times the number. So that's only one expression because there's no with or and or any separation statement or separation word. So what is the first word I should key into? Key into than. Than's where you key in, so we start on the right side. So we're doing 10 times the number first. How do I represent 10 times the number? 10n. 10 times n. Then I'm looking at the left side, which says 2 less than, or 2 less. So minus 2. And since we're not multiplying that to anything, we can leave it alone. We don't need to put parentheses around it. And just like that, you set up your equation. So guys, the hardest part is setting up that initial equation. So do what I just did. Break it apart, all right? Find those key words. So the biggest key words that we found was product, with, your thans, and is. Those are your key words because those show you where your separations are, all right? It also shows you where you start with each of your expressions. So again, biggest issue I always find is turning words into math. You need to find those key words to hook onto because that will then show you what order you need to write your expressions in. All right, does that make sense? Yes, no, maybe? Yeah. All right, now we're in solving land. So what's the first thing I should do if I want to solve this? I need to distribute. So in other words, I need to do some foiling or box method on the left side of the equation. So I'm going to do a quick box. So I have 3n minus 7 times n plus 1. So we're just doing a regular box method, not a reverse box, just a regular box method. So what's 3n times n? 3n squared. What's negative 7 times n? Negative 7n. What's 3n times 1? 3n. And then what is 1 times negative 7? Negative 7. So if I pull everything out of my box, including combining those two n's together, I would get 3n squared. What's negative 7n plus 3n? Negative 4n. And then minus 7 is equal to 10n minus 2. So now that we've done our simplification of both sides, now we can start moving things to solve. So if I want to solve by factoring, which is how you'll do most of these, what do I need to do first? Right, we need to get one side equal to 0, so we're going to start moving things around the equal sign. So the first thing I want to do is subtract that 10n. And which term on the left side do I subtract the 10n from? The negative 4n. So this goes away. I'm left with 3n squared minus 14n minus 7 is equal to negative 2. What's my next step? Add the 2, and what am I adding the 2 to? The negative 7. So the negative 2 plus 2 goes away, and I'm left with 3n squared minus 14n minus 5 is equal to 0. Now that I have one side equal to 0, I can go into factoring. So first off, do I have a GCF there? No. So I can go right into big X. What goes on top of the X? Negative 15. Why is it negative 15 and not negative 5? Right, because we got to do A times C. So this is ABC. All right. The top is always A times C. So we got to multiply that 3 to the negative 5. What goes on the bottom? Negative 14 or your B value. So I need two numbers that will multiply to negative 15, add to negative 14. All right, can anyone take a guess of what those two numbers are? 15 and 1, good. So 15 and 1, but since we're multiplying to a negative number, that means one of them has to be negative. So which one needs to be negative? The 15. because we want to add to a negative number. So if we're adding to a negative number, the bigger number is the negative. Now I'm going to throw ends after these because now I got to do a reverse box. So if I do a reverse box, what goes in the top left corner? Not 1n, but 3n squared. So remember, your squared value always goes in the top left. What always goes in the bottom right? The c value, or your constant, so -5. And then the other two boxes are for your two factors. So it would be -15n and 1n. And again, it doesn't matter where you put them as long as it's within one of those two boxes. Now, we always start in the top left corner of the box. What is the only two values that will multiply to 3n squared? N and 3n. Now, we got to pay attention to where we place the 3n. Should I place the 3n on the side of the box or on the top? Side. Why? Right. So I need to put the 3n here because if I put the 3n on top, there's no whole number that I can multiply to give me 1n. But there is a number I can multiply to 3n to give me -15n. So that means the n has to go on top. So 3n times what gives you -15n? -5. So that also goes on top above the 15n. All right. N times what gives you 1n? 1. So this would be +1. So my two factors are 3n plus 1 times n minus 5 is equal to 0. What's my last step for solving? Right, turn them into my two mini equations. So I'm going to set both factors equal to 0 and solve them separately. So for the first one, I'm going to subtract 1 first. I get 3n is equal to -1. Divide by 3. N is equal to -1/3. And then for the second equation, add 5 to both sides. N is equal to 5. Now, we're not looking for consecutive integers. We're just looking for rational numbers, which both these numbers are. Also, because we're just looking for numbers and not like a measurement, we don't care if that number is negative. All right? So both of our answers are viable. So the answer to this is that either one of these numbers, -1/3 or 5, if we plug them back into our original equation, it would work. So if we plugged it back into this equation up here, it would work. All right, we would get the same number on both sides. So both -3, or not -3, -1/3 and 5 would work in terms of our property. All right, so since I get a lot of sleepyheads, we're going to go ahead and take our 5-minute break, and then we'll come back and do those two consecutive integer examples. All right, so go ahead, take your 5-minute break, and then we'll come back and do the consecutive integer examples. Because we're going to be awake for the next one. All right, so let's go ahead and pick up where we left off with those two examples. All right, so I'm not going to. One second. All right, so we're going to pick up with example 2. All right, so shh. Now, we're now going to get into consecutive integer land. So let's look at example 2. It would help. Did it disconnect? Okay, so example 2, we're going to find two consecutive integers. So now we're in consecutive integer land where the product is 72. So first off, the word product, what does that mean? Multiplication. So we're multiplying, and it should be equal to from is 72. So first things first, we got to combine or define our two consecutive integers. So our smaller integer will always be what? What we use to represent the smaller integer. Boys, turn around. N. So our smaller integer is going to be represented by n. Now, the next one up, or our larger one, we will represent as what? Not n plus 2, because we're not trying to find even or odd, just consecutive. N plus 1. We just want the next number after n. Now, if we're going to set up an equation to represent the product of these two integers, how would I use the n and the n plus 1 to set up my equation? If I'm finding the product of them, how would I write it? So product means what, guys? Multiplication. So if I'm multiplying those two integers, not 2n, so we're just multiplying these two together, how would I write it? There you go. N times n plus 1. And it's all equal to what? 72. So now we can start solving for n at the very least. So what's my first step for solving? Distribute my n. I get n squared plus 1n, or just n, equal to 72. What's my next step? So we're still going to be solving by factoring. So I need to get one side equal to 0. So I'm going to subtract the 72 to both sides. And the 72 has nothing to subtract to, so we're just going to slap it on at the end of the expression. So this would be n squared plus n minus 72 is equal to 0. Now we're in factoring land. There's obviously not a GCF since our a value is 1. So I'm going to go right into drawing a big X. So what goes on top? Who? Right here. So negative 72 goes on top because that's my a times c. 1 times negative 72 is negative 72. You good, maybe? All right. What goes on the bottom? Just 1. So I need two numbers that multiply to give me negative 72, add to give me 1. What are those two numbers? Boys, turn around. Everybody take the hood off. So let's just list some factors of 72. What are some factors of 72? Just off the top of your head. 9 and 8. What's another one? 1 and 72. And you're close, it's 36 and 72. No, you're fine. And then 6 and 12. 3 and 24. 4 and 18. All right. Which one of those, if I made one of them negative, because we're trying to get a negative product, would add to 1? 8 and 9. Which one has to be negative if I want positive 1? The 8. So I have negative 8 and positive 9 as my two factors. So if I do a quick reverse box, I have n squared, negative 72, negative 8n, 9n. Now, this is an easy reverse box because what are the only two factors that give us n squared? N and n. So it doesn't matter where we put the n's because they're the same thing. N times what gives you negative 8n? Negative 8. N times what gives you 9n? Plus 9. Good. So my two factors are n plus 9 times n minus 8 equal to 0. What's my last step here? Write the many equations and solve them. So I'm going to write them over here. So I got n plus 9 equals 0. And I'm going to put parentheses there. And then n plus, not plus, n minus 8 equal to 0. So I wrote my two many equations by breaking apart my two factors. So if I solve them really quickly, you would subtract 9 to both sides, n would equal negative 9. The second one, you'd add 8 to both sides, and it would equal 8. Now, these are not your consecutive integers. These are just two of your smaller integers. So in other words, n could be either negative 9 or 8. So we need to find the larger of the two integers, or we need to find the largest integer after for both numbers. So how do I find the larger integer for both? I would do what to those two numbers? Nope. Add 1. So what's negative 9 plus 1? Nope. Negative 8. All right. What's 8 plus 1? 9. So we have two different pairs of numbers. So this is a pair, this is a pair. Both of them are consecutive integers because is it not true that if you're looking at a number line, negative 9 and negative 8 are right next to each other? Is that true? Yes. On a number line, they're right next to each other. Is 8 and 9 right next to each other? Yes. So these are both two consecutive integers. And both of them work because what's negative 9 times negative 8? Positive 72, which is what we wanted. What's 8 times 9? 72, which is what we wanted. So we have two different answers here. So the way we're going to write this is our answer is the set of negative 9 and negative 8 can work, or the set of 8 and 9 can work. So there's two different consecutive integers, sets of consecutive integers that can work for what we want it to be. So unlike with area problems, we can't just eliminate the negative. That negative is still part of it. But negative 9 and 8 are not consecutive integers. Because is it true that negative 9 is right next to 8 on a number line? So if I drew a number line, is negative 9 directly next to 8? No. There's about 17 units of distance between the two. Yeah. So, in other words, we got to use both of these n values as our smaller n, and then find the corresponding integer by adding 1 to both of these numbers. And we use our little squiggle brackets because we want to say that this set of numbers and this set of numbers would work for our purposes. We can't use parentheses because that would make it a point. There's a difference. All right. So make sure when you write your answers, you use your squiggle brackets and make sure you write the correct pairs together. Any questions on example 3? All right. Let's do example 3, example 2. All right. The last one we're going to do is example 3. So we're going to skip example 4 because it doesn't really deal with consecutive integers. So example 3 is find two consecutive even integers where the sum of their squares is 164. So let's break this down again. So first off, they want two even integers. So our smaller of the integers would always be equal to what? N. But our larger number, and it has to be even, and so does N, it also has to be even. What expression will we write for the smaller number, or not the smaller, the larger number? Not N plus 1, but N plus 2. Because we want both numbers to be even. So if we start with an even N value, we got to add 2 to it to get another even N value. All right. Now, it then says something a little bit different. So it's not necessarily product, but it kind of involves product a little bit. So the next part is that they say the sum of their squares is 164. So let's break down that statement. So what does sum mean? We're adding. Now, what does it mean if it's a square? We raise it to the power of 2. So we will have some number squared. We're going to raise that to the power of 2. And whatever that is, it's 64. So let's just find the squares first. So we're going to square both of our integer expressions. So how would I write the square of n? N squared. How would I write the square of n plus 2? N plus 2 all squared. So n plus 2 is in parentheses, and it's all squared. Now, it says I want the sum of those two squared. So what do I need to put between those two expressions? A plus. So we got one side of the equal sign. So is means equal. And this whole expression is going to be equal to what? 164. And just like that, we got our equation. All right. So again, if changing math into words or go from words to math confuses you, break it apart as much as you can. Just do one little piece at a time. All right. Now, we need to do some simplifying on the left side before we start solving. So the biggest thing I need to simplify is the n plus 2 squared. Now, we talked about this in the last unit. What is n plus 2 squared the exact same as? What's another way I could write n plus 2 squared? Nope. 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 How would I rewrite n plus 2 squared as an expression? So guys, if I'm squaring the entirety of n plus 2, what does it mean to square something?
Oh, and then plus 2 times 2.
Close. It would be n plus 2 times n plus 2. The parentheses mean they're together. So remember, if it's in parentheses, they're married, you can't separate them, especially since it has a plus. And because of that plus, we can't distribute the square to both these numbers. So it's not n squared plus 4. It would be n plus 2 times n plus 2. So we got to do a box method to simplify that. So if I do a quick box, we have n plus 2 on top, n plus 2 on the side. So I would get n squared, 2n, 2n, and 4. If I combine like terms, I'm going to bring down the n squared that's in the front of my equation, plus n squared, plus 2n plus 2n is 4n, plus 4 is all equal to 164. Now, what's the last thing I got to do to clean up the left side? Elise? Not yet. There's one last thing I need to do to clean up the left side of the equation. I need to combine my like terms, which are these 2n squared. So what's n squared plus n squared? 2n squared. Good. Plus 4n plus 4 equals 164. Now we can do as Elise said and subtract the 164 to both sides to get one side equal to 0. So I'm going to subtract the 164 to the positive 4 because they're like terms. So I get 2n squared plus 4n minus 160 is equal to 0. Now I'm in factoring land. All right. So what's the first thing I got to look for when I factor? A GCF. Is there one? You sure? Yes, there is, and it is 2. So I'm going to factor out a 2 from this entire expression. So I'm going to divide all three terms by 2. So 2n squared divided by 2 is n squared. 4n divided by 2 is plus 2n. And negative 160 divided by 2 is negative 80. And it's all equal to 0. Now, what did I say happens with numerical GCFs if you're solving? They just go away. They don't matter in terms of the solving. So all that matters is what's in those parentheses. So we can go right into big X. So what goes on top of my big X? Negative 80, because 1 times negative 80 or A times C, negative 80. What goes on the bottom? 2. So what are 2 factors of negative 80 that would add to give you 2? 8 and 10. And one of them has to be negative because we have a negative product. So which one has to be negative to get positive 2? The 8 has to be negative because we want a positive number when we add them together. So I can now do a reverse box. We're almost done. So I have n squared and negative 80 in their respective places. And then I break apart my b value into negative 8n and positive 10n. So what times what gives me n squared? N and n. And it doesn't matter where I put them because they're the exact same thing. What times n gives me negative 8n? Negative 8, so I'll write minus 8 over the negative 8n. What times n gives me 10n? 10, so I'll write a plus 10 next to the 10n. So my 2 factors are n plus 10 times n minus 8 is equal to 0. What's my last step for solving? Make the little mini equations. So I'm going to set n plus 10 equal to 0, n minus 8 equal to 0. So subtract 10 from both sides, I get n equals negative 10. Add 8 to both sides, I get n equals 8. So these are my 2 smaller integers. So these are my smaller integers, which, by the way, another way to write integers is just like a Roman numeral 2. So an I with 2 lines, essentially. So my smaller integers are negative 10 and 8. So those are my n values. So n is negative 10 or 8. So that means to get my larger, I need to do what to both of those numbers? So to get the larger integer, I have to do what to those 2 numbers? Add 2, because that's what it says. N plus 2 gives us our larger. Well, we already have n. So what's negative 10 plus 2? Negative 8. What's 8 plus 2? 10. So these are my 2 sets of consecutive even integers that fits our scenario. So we would write it as the set of -10 and -8 would work, or the set of 8 and 10 would work for our answers. Now, I will say that on your delta math, you will sometimes see where it says, just give me the positive version of the integers. So if I asked you just for the positive consecutive integers, you would give me the 8 and the 10. If I asked you for the negative, you give me -10, -8. If I don't specify, you give me both. Yes. Yes. All right. So there is a new delta math for you guys. You can do it in Starbucks mode. I don't